All right, today we're going to look at the unit circle. Knowledge of the unit circle is critical to success in calculus. It's important that you're able to know what the values of certain radian measures are, as well as how to evaluate trigonometric values and where these all come from. So we're going to start by reminding ourselves that the radius of a unit circle is in fact a unit, and also of our trigonometric functions. We have sine, cosine, tangent, and their reciprocals. So if you have the sine of theta, remember that sine is the opposite over the hypotenuse. I'm going to abbreviate these. The cosine is the adjacent side over your hypotenuse. And the tangent is your opposite side over your adjacent side. And when we're talking about opposite and adjacent, we're talking about of the angle. Now we have cosecant, which is this reciprocal of sine, or hypotenuse over opposite, hypotenuse over opposite. The reciprocal of cosine is secant, which is hypotenuse over adjacent, and then cotangent, which is adjacent over opposite. So again, if I have a triangle or an angle that I'm dealing with, this angle theta, this is our adjacent side, this is our opposite side, and this is our hypotenuse side. The hypotenuse is always across from the right angle. Now, when you're talking about the unit circle, when your hypotenuse is always 1, whenever you're dealing with the adjacent and the opposite, you wind up simplifying. So the sine of some angle is going to be just the opposite. The cosine of some angle is just going to be the adjacent side. Now, when you're talking about theta and you have opposite here, the opposite, notice that that is just your height or your y value. The sine is the same thing as your y value, and your cosine is the same thing as your x value. So if I was to say sine of theta, that's equal to y, cosine of theta is equal to x, and the tangent of theta is equal to y over x. And so we'll be using those ordered pairs of the different theta values for the radians that we have to help us determine what the value of sine is and what the value of cosine is for the different radian measures. Before we can do that, we have to know where these certain values come from. So I'm going to switch down to some triangles here. On the left-hand side, we have an equilateral triangle. And what we know about an equilateral triangle is that all three angles are 60 degrees and all three sides are equal. Now I'm going to call this 1/2 x and 1/2 x because those two added together make that whole side of x. And that also means that this angle here is 30 degrees and this one is 30 degrees. Now if I'm considering, we have a 30, 60, 90 triangle now. If I'm considering that hypotenuse, it's across from my right angle, we know that that's 1 in the unit circle. And we're saying that if that's 1, then this is 1/2. But what is this other side? Using the Pythagorean theorem, we can determine that 1 squared equals 1/2 squared plus b squared, or 1 equals 1/4 plus b squared, or 3/4 equals b squared. Square rooting both sides, we get the square root of 3 over 2 is equal to that side. So this would be the square root of 3 over 2x if I was keeping the x, or the square root of 3 over 2. So opposite the 60, or the sine of a 60 degree, is root 3 over 2. The sine of a 30 degree, opposite 30 degrees, is 1/2. So we can use that in our unit circle in just a minute. For a 45 degree triangle, that's an isosceles triangle. We know that both of these angles are 45 degrees. And both sides are equal when we have a isosceles triangle. Those two sides are equal, so 45, 45, 90 triangle. We also again know that this radius is 1 for a unit circle. And so if we know that these are both the same value, how does that work out? Well, we can call this c. So we can say that x squared plus x squared equals c squared, or c is 1 in this case. So we have 2x squared equals 1, since c is 1, dividing by 2, we get x squared equals 1/2. When we're square rooting, we get the square root of 1/2, which is 1 over root 2 because the square root of 1 is 1. So x equals 1 over root 2. And we typically rationalize that because we don't like square roots in the denominator. So we multiply by root 2 over root 2 to rationalize. And we get the square root of 2 over the square root of 4, which is just 2. So now we know that this value is going to be the square root of 2 over the square root of 2. Since we knew that our hypotenuse was 1, we were finding our x, which was square root of 2 over 2. And now we have all the tools that we need for common values of a unit circle. How does that play in with our pi values, though? If we have 30 degrees, 45 degrees, 60 degrees, 90 degrees, 0, these are our common values, and then for each quadrant. This is all in the first quadrant. Now, what is that as radian? Well, if you take your degree and you multiply that by pi over 180, you get your radian. So 0 is obviously 0 radian, but 30 times pi over 180 is pi over 6. 45 times pi over 180 equals pi over 4. 60 times pi over 180 equals pi over 3. And 90 times pi over 180 is pi over 2. Okay, let's go back up to our unit circle now and fill in these values. This value right here is 0. It's also the same thing as 2 pi if you're doing a full circle. 90 degrees we said was pi over 2, which means that 180 degrees is pi. And then down here we have 3 pi over 2. And I've made in the positive quadrant, we're going to call this 30 degrees. That's going to be our pi over 6. Our next angle would be 45 degrees, which is pi over 4. And then our final angle is going to be 60 degrees, which is pi over 3. Now, filling in those values for the ordered pairs, remember that the opposite is going to be your y value, and the adjacent is going to be your x value. So we can go back down to our 30, 60, 90 triangles. We can actually write those values here. So for our 90 degrees, remember, our hypotenuse is 1. This is our 60-degree angle. This is our 30-degree angle. And so for the 30, we have 1/2. For 60, we have root 3 over 2. So the opposite, or the y value for 60, is root 3 over 2. Which means the adjacent is 1/2. And notice that the opposite, the coordinates actually switch for 30 degrees. So it becomes root 3 over 2 as the adjacent, and then 1/2 as the opposite. And for the isosceles triangle, we had root 2 over 2 for both values. So the ordered pairs just winds up being the same. We have root 2 over 2 and root 2 over 2. Now, I could go into the second quadrant, and let's say I had 4 pi over 3. I would then be just using these values in the second quadrant. So I could do any of these values here. And they're all going to be some form of those values we just did, but it all depends on the quadrant that you're in. So in the second quadrant, our x's are negative and our y's are positive. In the third quadrant, both our x's and our y's are negative. And in the fourth quadrant, our x is positive and our y is negative. One thing to note when you're doing your different angles is that if we have the unit circle here, you're actually taking the angle, it's kind of like a butterfly. Here, for the first quadrant, it's always this angle. The second quadrant is this one, third quadrant here, and fourth quadrant. So if I'm trying to figure out what this 4 pi over 3 value is here, I'm going from this triangle, which has 60 degrees here, 30 degrees here, and 90 here. So this is the same 60 values as to the right. It's kind of like a mirror image here, except that the x is now negative. So I have negative 1/2 and positive root 3 over 2. Okay, Same thing for the pi over 4. I'm going to have negative root 2 over 2 and positive root 2 over 2. And then I'm going to have negative root 3 over 2 and positive 1/2 here. These two are going to be mirrors of each other because this angle works here, this angle here, so you're drawing your lines of the triangles this way. So when you're trying to use your 40, 45, 45 or 30, 60, 90 triangles, in this case, you've got negative values for both your x and your y's. And then finally, same thing. These two values are going to be the same, except your x is going to be positive and your y is going to be negative. And this is positive. The only values that we're missing now are these values on the axes. Well, for 0, it's not 0, 0 as your ordered pair because your x value is 1. So you've got 1, 0 here, negative 1, 0 over here, and then 0, 1, and 0, negative 1. And that completes our unit circle.